So this part of the lecture is on chapter number 5. And chapter number 5 is for those of you who have taken undergraduate database class. This is a big part of it conceptually in designing a database. For this particular textbook, as well as in many real-world situations, the reason you are conducting entity relationship model is to design a new database from the ground up. So assuming that you do not have anything, then you are asked to build something. Say you go to a company, they're telling you, oh, we need to have a customer database, and so you start building database from nothing, right? So that's a typical case when you conduct entity relationship diagram. Um, the assumption from me is that, and actually from your textbook as well, is that do you think you will have the opportunity to design a new database anytime soon? The chances are very low, right? Most likely, in the real world situation, you will not design a new database. You will be using a database more than designing a new database. So when we are looking at this chapter, we'll have to look at this method in a different perspective. But your textbook introduced in the perspective where we're looking at from the purely design new database perspective. So that is one of the assumptions I want to tell you when I start the chapter. So when you are working on this assignment, and do remember that the ER diagram or ER model assignment does not have correct answer, right? It has only recommended model. It does not have a answer to a particular problem you are modeling, right? Why is that? And we'll probably learn some of the reason why when we get into the point. And one of the short answer to that question is that the data model is a way before we build anything to conceptualize, right? The keywords is conceptual. Conceptualize what are logically required for that particular problem or the application you're building. Now, in a typical software engineering or system analysis and design project, we usually call this either as conceptual model or sometimes you heard about this term logical model, but I'll try to avoid that. Or using the terminology as the domain model, right? So if you hear about this other term called domain model, we're typically talking about entity relationship model here. So for if you refresh your memory, if you have taken MIS 552 from our program already, we did talk about domain model in one of the chapter, and that is we are using UML diagram and we are using UML class diagram to represent the domain, right? And the entity relationship model or the data model we are looking at in this course is similar concept, but focus more on database or data-driven application, right? So when you are dealing with database-driven application, the first thing you analyze is not the application itself, it is the data itself. So we start by building a domain model from data. So the domain model is a data model. It's a part of the thing we do in conceptual design. That is some of the thing. Oh yeah, so the term I use, conceptual model, logical model, physical models are showing up here. Now, one note I try to stay away earlier when I say the domain model, sometimes called logical model, is because logical model in the database world, which is the world we are in now, in this particular case, has a special meaning. Now, it's a something we call the logical schema. Right? So, what exactly is a logical schema? A logical schemas are the notation you see in chapter 3 and chapter 4. So when you look at something that we try to describe a table, you use this blue table. I don't have a slide here, but if you go back to chapter 3 and chapter 4, when we try to describe a table, say a student table, you put a student capitalize student words as the table name and use a parenthesis to represent the table and use a comma to separate the column within each one of this table. That is called the logical schema. And that particular way of describing a table or their relationship is not sufficient for implementation because they are not really database language. If you convert that logical or that schema language into SQL statement, SQL statement is a select statement, create table statement, create view statement we just learned in the previous assignment supplementary. And those are, when you are using the actual SQL language to describe your table, it becomes physical. And why we call that physical? Because physical schema means that you can actually read by a physical database management system and actually run and execute. And just to give you more reference point from your experience in this class is that at the beginning of the semester, before we work on any assignment, you are asked to run script. And when you run the script, the database will be recreated in your database schema or database account, and you make a connection, you can see those tables. And those scripts are physical schema, right? Those scripts, when the database engine read it, it can be executed. And because it's directly doable, it's called physical. If it's not directly doable, it's called logical, right? And if you present them not even in the schema language, verbal format, in the especially graphical format, like what we are seeing here later in a few slides, we call them conceptual model, right? So that's the difference between these three here. And the ER diagram model is relatively new. Well, it depends on how you define that as new. It was actually invented in 1976 by a professor called Peter Chen, and I really like this professor. There are several reasons for it. One is that this professor, I met him in person about 5 or 10 years ago in a conference in Omaha, Nebraska, when we had a conference there. And the second thing is this professor is originally from Taiwan, and it happened that your professor here is originally from Taiwan as well. So I like him a lot. He's a very nice person, very. And this ER model was Dr. Chen's PhD dissertation when he was a student at MIT. Right? So he's a graduate of MIT. And he's already retired. Before he retired, he is a professor at Louisiana State University in Baton Rouge, Louisiana. So yeah, but very very nice person. And this turned out to be the thing that people use pretty much like a Bible in the database world already. So the notation we're going to be seeing later will be first of all, the first few slides is coming from Dr. Chen's original notation. But after a few slides, the notation switched to another notation called the extended ER model notation. And we will see those as well. Because over time, and in the field of information technology, there are a few competing paradigms are competing in terms of software development. And so the database or data-oriented environment learn a lot from the object-oriented world, and some of this concept from object-oriented world being implemented into the ER concept, it becomes extended ER model. So that will be another set of notation. But after that segment, your textbook switched to the notation that I'm going to be asking you to do. It's called a Crowfoot notation. Right? The Crowfoot notation is probably the most popular notation we see in the database world. And we will see all three different notations. And when we reach that slide, I will tell you what kind of notation we're using. Right? So these are graphical language, and in a way that in information system world, we are dealing with language Could be a graphical, could be programming language, or could be jargon and terminology. All these are language game. By the way, that it is very important if you compare the thing called information system with language. Otherwise, we will not call the programming language as language. And a lot of the earlier good programmer, genius programmer, actually have linguistic or language background. A lot of my colleagues, actually not colleagues, I should say some classmates and friends in the process of learning, and they were major in like a Chinese literature or English literature or French literature when they are studying undergraduate degree. But when they moved to the United States and decided to find a discipline to find job, and they select computer science. Many of them find very reasonable fit between the study of language and computer science. So that there is a connection there. So don't think that if you are a liberal arts major, you're not good at a computer language. Just the contrary, it's actually a very good fit, especially when we are entering this low-code AI environment. A good language training is extremely important. And if you have a chance of talking to the video game developing company, you will know that the bottleneck of video game developing is not about programming. It's more on the story you write for video game, right? So who creates a story? People with imagination, people with a strong literature background, people are exposed to various kind of a way of storytelling. So that part is very important. In a way, writing programs like telling a story in different way. But we'll move to that part. Some philosophical lesson I want to share with my student as well. All right, so let's get started with conceptual modeling before we move too far from the talking of language and literature. And so entity relationship diagram is a way of organizing data into reasonable set. Yes, I have a question here.
Now, Professor, what you said about philosophical and literature, it was interesting to know. I was very learning here.
Yes, very good. So yeah, again, the storytelling method are actually one of the things I would recommend everybody to do as a personal training method is, that we in the business world today, one of the important skill people keep saying is the communication skill, and the communication skill, of course, include the presentation, how you present, both verbally in real time or using verbally in writing format, and or somewhere like in data format is also a form of communication. And when we enter the new millennia after 2000, we are entering the age that you're combining all these different methods into one form. So every time you see a video, it's not only a video; it's a combination of video and data and probably a story. And every time you read a book, it's not only a book. There are a video audio component might go into a book. So those a combination way of presentation become very important skill for every one of us to learn. And so this is why I kind of emphasize. So whenever you look at the data or the dashboard we are building in the class right now, it's no longer a technical component. It's part of your communication skill you use to communicate to other person. Right? Yeah. Thank you for bringing that up. Give me 2 more minutes to talk more on that topic. Okay, so the entity relationship diagram, again, I want to repeat myself, is a way of organizing concept or organizing data. So the key is, how are you going to be organizing data? Now, the traditional way of organizing data in a human society is a hierarchical structure, right? If you think about how do you organize how do you organize your company, the company you work for? How do you organize the university structure? We are working here. It's all hierarchical because we are we are subjected to the Industrial Revolution. The Industrial Revolution introduced the idea of the company organization and enterprise organization, and the discipline of called scientific management. You probably learned that from your economic classes. Frederick, what's his name? Frederick. I'm very bad at remembering name, but anyway. So the scientific management is basically create this hierarchical division of labor that very strong, highly centralized, controlled institute to increase the efficiency of any structure. So our brain, in a way, is trained to learn or actually try to accept the hierarchical structure. So the government structure is hierarchical, university structure is hierarchical, and the what we call education system is also hierarchical. So very naturally, when we design, when we means that human being or the computer science will try to design the first generation of the database. The database is hierarchical. So you create a tree, and the tree has records, has field. So those terminology, record, field, we use in normalization theory. I told you that try to avoid because that represent a hierarchical structure. But of course, hierarchical structure has a benefit and disadvantage. The most important disadvantage is hierarchical structure is very rigid, very difficult to change. And this is why we have this terminology called bureaucracy. And bureaucracy usually represent a system that is hard to change, hard to, it's not flexible enough to adjust to the job you're assigning to do, right? So modern management theory is that we are creating, and this is kind of connecting to your other management class, creating temporary project team. So it's more like a temporary team-based project organization structure. Instead of, yes, you still have that hierarchical, but your job assignment is project-based, right? So that's become a typical, because you will not be doing the same job for 20 years anymore. You will be learning new skill, doing new project all the time. So your job assignment is doing that as well. So the new organization structure is team-based, and translate that into database design, right? So earlier we talked about organization design. When we translate that into database design, and a nature way of doing that is also team-based or group-based. So I like to use the word group to start introducing the concept of entity, because entity is a group. So now let's get into the terminology of entity relationship diagram. So team, group, entity, class. Right? So these four words, I like to kind of put them together. So anyways, what's the next time you talk to people about entity, you have to remember entity represent an entity class here on our slide, or entity group, or entity team. And it always means there are multiple members in that particular concept you try to organize or try to put together, right? So entity class. But if you want to talk about a specific data record or data row, data item, you have to use a term called instance to describe that group of data that you try to describe. Say, for example, if you are talking about student record, student data at UIS, student data, when you talk about student data, it refers to all the students as a group in UIS. So it will be a huge table for student data. But when you talk about the student, say Taewei Wang, your professor, I'm also a student too, as a student, then you're talking about that particular instance of the data. We use a term called entity instance. So individual student is the instance. But if you talk about a student as a group, we use this term entity class or entity only. So in the future, when we say entity, it refers to the group. It refers to entity class. When you try to describe a particular record, we have to specifically use the term instance to describe it, right? So that's the jargon and the language we are using here. So here's an example of to differentiate the difference between entity and instance. Right now, before we get into this example, let me try to refresh your memory a little bit from normalization theory. So normalization theory, at the end, almost near the end of the lecture, we were talking about this BCNF, right? Boyce-Codd normal form. And one of the examples your textbook used there was that, and Boyce-Codd normal form is specifically referring to you have a candidate key, right? Candidate key again is the a key that can be potentially used as a primary key in a particular table. You have a composite candidate key. Composite candidate means that that key is consist of multiple columns to become a key. And one of the typical composite key that can be used as a candidate key is this thing here called the address. So the address has three addresses. You have a city, you have a state, you have a zip code in the United States at least. And this format, this four column, yeah, if you think about this, how do you organize these four columns in your database? Do you use one column to store all the information, or do you separate them into multiple columns? Right? The best practice, and at least from the experience we have, you go into Outlook, they will ask you to enter each one of this information separately, so you know they are put into multiple columns. And we know that you put all these columns together, street, city, state together. These three columns become a unique candidate key, which means that these three columns they identify a particular address already, right? So that will become a problem. We in normalization we call the Boyce-Codd normal form problem. Multi-column candidate key is not used as a primary key, so we create some sort of a alternative method to make sure this problem does not exist. And your textbook actually recommend in this case we don't need to achieve the BCNF, right? So, but in coming back to this example here, that is the concept of address now is the concept of data organization we are talking about here. So on this particular slide, you see we have an example of entity called customer showing as an example, right? So customer as an entity, if you does not dig deep enough, you can naturally accept that this is an entity, no problem, right? So student is an entity, no problem. It seems like physically it's just an entity, so good. But if you think about address, should address be part of the customer entity, or should address be an entity itself? Right, think about that question. Right. So when you start to question that, should I put the address into a separate entity? Because address and customer are two different concepts, or address and student are two different concepts, right? So if each concept is a group itself, but an address should be separate into an entity now. Right? So, but also that when you are recording a student record, you also want to record the address. But this become a sort of like a paradox or conflict in our logical thinking that, well, yeah, if you think deep enough, this is a separate entity. We shouldn't be put address into the customer. We should use address or create another one on the side that address is a separate entity and try to relate the address to the customer. And so that is actually becoming a problem. If you never see that problem before, now I'm presenting that problem to you. Hopefully you can get what I mean by that is a problem. So there is a decision to make now, and this decision is what we call as design decision, because now we are designing database. Do you separate address into a separate entity, or do you include address as part of the customer entity here as your design, right? And that is a decision. And which one is correct? The answer is I don't know. It's the best way to get rid of the results. Yeah, the answer is I don't know, right? But I do know some principles that you can use to make judgment. Which one is better, right? So I say better, not good, good and better. It's a better decision. So the principle here is this: in the normalization, we have a concept called multi-value dependency. If address in your business problem is a multi-value dependency problem, then you separate that concept in this case. If it is not a multi-value problem, you keep this in as an attribute, right? I'll pause here for a while to see if there's any question here. All right, so let me repeat one more time. If you have a multi-value dependency relationship situation, you put the address as a separate entity. But if you do not have the multi-value dependency concern, then you put the address back in. What do I mean by that? In practice is that in your database, if you want to, for every customer here, if you want to record multiple customer address, his home address, his office address, his second home, his vacation home. If you want to create multiple of this person's address, then you want to separate address into an independent entity. But if you only want to keep one contact address, then there's no multi-value problem. Right? So it depends on your business need. Then you decide on what is the best design for you. So because this is a design problem, there is no correct or incorrect. There is good or better depending on your business situation. Right? So that sentence I will doing a few times because when we are discussing design, good and better is better than the correct and incorrect. Right? So that's the way to do it. Right. So let's go back to the notation we see on the screen. The notation you're seeing on the screen is a combination of the extended ER diagram notation as well as UML notation, right? And it is a ER diagram notation because it's not it's obviously not a class diagram here, but it looked like a class diagram, looked like a class, so it's actually part of UML notation. And one of the trivia detail that I'd like to share with you is that if you look at the top of the screen, it's a entity. Lower part of the screen is two instances of that particular entity. And other than the colors are different, there is one significant difference. Pause here for a while so anybody can notice the difference between. One second. Well, one of the main differences in here is that it is in the lower part of the slide, it shows the value of that particular attribute or column. So instead of says a customer number, you see an actual value. So it's 1234 or 99890. So when you see a value, it's an indication of an instance. When you see a description of a column, that is the entity. Right? So that's one major difference between entity and instance. And the other very trivial differences I will show you here is that if you look at the blue entity on top, it's actually more like a three-dimensional rectangle instead of a two-dimensional rectangle. It has a shadow, right? So that what does shadow mean? Shadow means multiple. It's kind of like a layers of paper you put together. So that shadow represents a group. So the notation-wise, the shadow represent that class or group or entity concept, right? So value and the shadow are two sort of like a small differences, but a big indication on what you're seeing there. And so in each one of these entity, you define them by their attribute, right? And of course, attribute later when we implement into database become column. So columns and are the implementation of attribute. The attributes are the characteristics of that entity. So again, this leads to some of the philosophical discussion about what does that mean by entities characteristic. So is a customer's address considered to be his or her or characteristic? Again, the reason I say this is a philosophical debate is because it is. Uh, Address is not part of a person. Well, how can you put that as a characteristic of a person? So but on the other hand, it is associated with you very tightly. You have a contact address, so that's also so that become and the reason the original ER diagram can become a PhD dissertation in MIT was because this is related to some of the nature of philosophy. And one of the foundation of the philosophy is that it's called the logic. To just give you a brief understanding of what I learned from my PhD program is philosophy is one of the main discipline in philosophy is logic. So what does that mean by logic? Logic is actually very simple. Use the minimal vocabulary you can find to define as clear as possible the universe. Right? The universe has a lot of things: concept, object, things, physical or not physical, conceptual things happen, temporal. Some of them are eternal. All the things you want to use the minimal language to describe and to define every one of those things. That is the foundation of logic, right? And that is a field of the logic we call ontology, by the way. And so the visual modeling, data modeling, is actually under the philosophical study in the computer science field called ontology study. So we study the ontology of this. How do we organize, put things into group together, right? Almost like we are like the modern day Darwin, and try to put animal into different group, and we're doing the same thing here. When you are managing data, you're putting data into different groups so you can manage that, right? So it's kind of similar concept. You're managing animal is kind of you're managing data. So the debate or the consideration in design will be, what is the best way in your particular problem you try to solve? How do you manage that best, right? So that's the thing. So now we discuss the attribute. Again, go to the concept of design, or what is the best way to identify the attribute. The answer to that is, again, I don't know. It depends on your business need, and there is a better way of doing things, but there's no correct way of doing things. All right. So I'll stop the recording here by introducing the foundation, philosophical foundation, and connection of ER diagram to other problems such as normalization in this lecture, and then we'll move on to the next recording for more extensive ER discussion.